Good morning students. Today we will be dealing with the second topic of the chapter sound. Okay. So in the last class we learnt about how sound is produced and how it is propagated, and we came to a conclusion that sound is a form of a mechanical wave which moves from a source to listener through a medium, and it requires a material medium for its propagation. Sound is a mechanical wave and it requires a material medium for its propagation. And normally a mechanical wave is categorized into two. So normally a mechanical wave is categorized into two. First one is a transverse wave and second one is longitudinal wave. So sound wave is an example of mechanical wave and it has two categories: transverse and longitudinal. Okay. And sound waves in air are longitudinal waves. Sound waves when propagates through air comes under the category of longitudinal waves. To understand what it implies, first we need to understand what is transverse and what is longitudinal waves in detail. Now let us come to the topic transverse waves. Okay, and in transverse wave, if wave propagates in this direction, if this is the direction of wave propagation, wave started from this point and the disturbances are propagating from left to right, that is in this direction, the disturbances are traveling in this direction, the particles will vibrate, the particles will have a up and down vibration. The wave will pass from left to right, but the particle will vibrate up and down. That means in transverse wave, if direction of wave is this, the particle vibration will be in this direction, that is the direction of vibration of particle and the direction of wave are in perpendicular direction. That is, the particle will vibrate perpendicularly to the direction of wave. Wave povunna direction perpendicular aayittirikkum particle vibrate cheyyunnathu in case of transverse wave. To understand it, take a string and attach one end of a string to a window. Now take the other free end and make it vibrate. Make it vibrate, and that string vibrates in form of transverse wave. That is, waves will pass from our hand to the direction of window, but the particle will move up and down. The particle of the air will move up and down. That is an example of transverse wave. For that, this activity you can do it at home. That is, take a string. Now tie a ribbon onto that string. Okay, as we do for a tug and war competition. Okay. Now tie one end of the string to a window. Take the other free end in your hand and make the string vibrate. Just move the string up and down, so that the string will vibrate. You can see that the string, a waveform will be created in the string which moves from your hand to the window, while the ribbon that you have tied onto the string will move up and down. That is a particle. So the particle will move up and down while the wave will move from your hand to the window. So the particle movement will be perpendicular to the direction of wave in case of transverse wave. Another example is take a tumbler and fill it with water. Now put a pebble into it. We know that a ripple will be formed. The ripples formed is a kind of transverse wave. Now just put a dry leaf onto the surface of water where the ripple is formed. We can see that the leaf will not move from one point to other, but they will just vibrate up and down. They will just move up and down. They will not move with the waves. They will not go with the waves. They will just move up and down in their respective position. Such kind of wave is called transverse wave. The particle will not move from one point to another. Only disturbances will be moved, and the movement of particle will be perpendicular to the direction of wave. So if wave is moving in this direction, the particle will have a up and down movement. Such waves are called transverse wave. And the peak point of the transverse wave are called crest, and the valley point of the transverse wave are called troughs. So in a waveform, a wave has a peak point and a valley point. This valley point is called the trough, and the peak point of the wave, is called crest. So the two parts of the wave are the peak point, which are called crest, and the valley point, which are called troughs. So these are the two parts of sound wave. Okay. Now let us come to longitudinal waves. In longitudinal waves, the vibration of particle and direction of wave are parallel. If wave moves in this direction, if wave is moving in this direction, the particles also vibrate in this direction. The particle will have a to and fro motion which is parallel to the direction of wave. So particles perpendicular ആയിട്ടാണ് move ചെയ്യുന്നതെങ്കിൽ it is transverse wave. If particles are moving parallel to the direction of wave, wave പോകുന്ന അതേ പോലെ തന്നെയാണ് particle move ചെയ്യുന്നതെങ്കിൽ it is called longitudinal waves. And it is just similar to the case of the excitement of tuning fork that we have discussed in video number 1. An example of longitudinal wave is the wave created by a slinky. The wave created by a slinky is an example of longitudinal wave, and it is just similar to the one created by a tuning fork. When a tuning fork vibrates in such a manner, to and fro motion will be like this, and a wave will be created in this manner, and finally it will reach the listener. So when the tuning fork vibrates, it pushes the air in front of it, which creates a high pressure region called compression, and when the tuning fork relaxes, it creates a low pressure region called rarefactions. So in longitudinal wave, we have a series of compression and rarefactions. So in longitudinal waves, the particles vibrate parallel to the direction of wave, which creates a series of compressions and rarefactions. That is longitudinal wave. Now let us see the comparison. This is the case of transverse wave. In case of transverse wave, the particles will move up and down with the direction of propagation of wave. If this is the direction of propagation of wave, this is how the particles vibrate, which creates such a form of wave, and the peak point of the wave is called crest, and the valley point of the wave is called trough. Okay, while in longitudinal waves, if this is the direction of wave, the particles also vibrate parallel to the direction of wave, which creates a region of compression, high pressure region called compression, and the low pressure region called rarefaction. And this longitudinal waves consist of a series of compression and rarefactions. See, this is the crest portion of transverse wave, where the density of particle is high, and such point corresponds to the high pressure region called compression. And the valley point of the transverse wave, that is the trough, corresponds to the low pressure region called rarefaction. Again, the crest of transverse wave corresponds to high pressure region called compression. The valley point of the transverse wave corresponds to the low pressure region called rarefactions. That is, in longitudinal waves, it has a series of compression and rarefactions, while in transverse wave, it has a series of crest and trough. Crest corresponds to compression and trough corresponds to rarefactions. So, once again, in transverse wave, direction of movement of particle and direction of wave are in perpendicular, which creates a series of crest and trough. The peak point is called crest and the valley point is called trough. While in longitudinal waves, the particle will move parallel to the direction of wave, which creates a series of compression and rarefactions. The high pressure region is called compression and the low pressure region is called rarefactions. The crest of the transverse wave corresponds to compression of the longitudinal wave, and the trough of the transverse wave corresponds to the rarefaction of the longitudinal wave. And the sound wave through air is an example of longitudinal wave, which creates a series of compression and rarefactions. Hope the difference between transverse and longitudinal wave is clear. Thank you.